What's up, everyone? Welcome back. Today I'm going to show you how to install kube-vip on an RKE2 cluster that we're going to build manually, as well as an RKE2 cluster that was launched by Rancher 2.6. Let's get started. If you watched my last live stream, you saw that we tried to deploy kube-vip into an RKE2 cluster that had been deployed by Rancher, and we hit some snags. I've resolved those snags, so I want to show you the right way to do that so that you can use kube-vip in any RKE2 cluster. Also, in an earlier video where I used kube-vip with MetalLB on K3s, some of you asked me why I used both kube-vip and MetalLB when kube-vip can do the same thing that MetalLB does. The reason is because at the time that I made the video, literally while I was recording it, there was a bug in kube-vip that broke LoadBalancer Services. So the only thing we could use it for was to provide a floating IP for the Kubernetes API. He fixed that literally around the same time that I released the video. So I want to follow up and show how you can use kube-vip to do everything. Now, whether you choose kube-vip, MetalLB, or a hybrid of the both is entirely up to you. But today we're going to do it with RKE2. So let's start by deploying a standalone RKE2 Kubernetes cluster. When you deploy RKE2, one of the options that you have available is to use a config file to define some of the stuff that you would otherwise put as environment variables or flags at the time that you launch it. I have three configs. I have three servers, A, B, and C. Config A, well, it's pretty basic. The main thing that's important to talk about is the TLS SAN variables. So these are going to be additional names that are added to the certificate that the SSL component will respond to. If kubectl connects to a server whose name is not in the certificate that it receives, then it just fails. So we want the API server to answer to everything. The thing about RKE2 is that we're going to build each node independently and then have them join the cluster, so we can have a separate config file and ultimately a separate cert for each of them. So we only need demo A to respond to its own name, B to respond to its own name, and C to respond to its own name. This is different from how it works with a Rancher deployed cluster, as you'll see a little later on in the video. So here I am logged into all three nodes, and we're going to do this one where we're actually just going to bring up a single node and install kube-vip into it, and then use that floating IP to join the other two nodes. You don't have to do it this way, but it gives a nice demonstration of the fact that it's actually working the way that it's supposed to work. So on demo A, I'm just going to set some variables. The VIP, this is the IP that we're going to use. The tag is the version of kube-vip, currently at 0.3.8. My systems are running on Proxmox, and they're using an interface ENS18. Set that to whatever your own environment is using. We've got a couple of variables that help CRI-CTL and the CTR command figure out where RKE2 is actually running the containerd socket. kubeconfig and the kubectl path are also both different, and then just an alias for k equals kubectl. So with those set, we need to just get the config over from outside. And now we can start to install RKE2. What this just did is copied the config file to etc rancher RKE2 and then began the RKE2 installation process. It takes a minute for RKE2 to come up, so I'm just going to fast forward. All right, that's done. So the next thing is we need to get the token from the server so that we can join the other two nodes. I'll just grab that and copy it over into the other two config files. Config.b and config.c are almost the same as config.a, except for they have different names, obviously. But the FQDN and the IP are both the same. And the server information tells it where to connect. We're using demo cluster, which resolves to that 1068.0.81 IP. Back over here on demo A, let's continue with the installation of kube-vip. RKE2 operates like K3s in that there is a directory in which you can place Kubernetes manifests and the server will just install them. It's constantly watched. So what I did there, let me scroll back up, is I first pulled down the kube-vip RBAC file, threw that into that directory, and that got installed into the cluster. Then I pulled the actual current container image for kube-vip, and then I set up an alias so that we could just type kube-vip and it actually ran CTR, -- namespace, and so on and so forth. Now the use of -- namespace kates.io is important. On K3s, when you run the CTR binary, it's a link to the K3s binary, which actually already has the namespace set. Now the namespace is relative to containerd, not namespace like in Kubernetes. It functions similarly in that they're buckets where container images and things are segmented and where they can be stored and run. But on RKE2, the CTR binary is not linked to anything that has the namespace set. So when I ran CRI-CTL pull, that pulled it down into a specific namespace. But if I were to just run CTR run, it doesn't automatically look in that namespace. So I have to specify the namespace that we want it in, which is kates.io. After that, I ran that kube-vip command with a bunch of different options. It's going to make a Kubernetes manifest to run kube-vip as a daemon set. We're going to use layer 2 ARPing because I don't have a BGP infrastructure. We're going to use the interface that we set earlier. We'll set the VIP address to that .81 address. We want it to load balance the control plane. We want it to do leader election between the different kube-vip pods. We want to taint the workloads so that they only run on the worker nodes. We want to enable kube-vip to also work for LoadBalancer Services. I don't actually know what the in-cluster option means. It might not even be necessary. It was in the documentation at some point. And then finally, we're just going to write all of that out to a new manifest called kubevip.yaml and put it in that watched directory. You can see the manifest that it created, and that got dropped out there. And by now, there's a pod running. And if we look at its log, you can see that it's ARPing for that .81 address. Let's just ping that. It's up, it's good. Now we can bring up our other two nodes. Let's copy their configs over. And back on the nodes themselves, let's do that to set all of our environment variables. And let's install RKE2. Down on this one, same thing. And here on demo A, let's just set a watch. And it's going to be the same thing. B and C are going to take a minute to come up, but when they do, they'll just appear here. We'll fast forward to that part. Actually, there's something else that I want to point out. Notice that the systemctl start on demo B was fine, but it failed on demo C. This is new behavior for RKE2. If you bring up the other two nodes at the same time, the second one is likely to fail. If we look at the logs, the reason for that is because there are too many learner members in the cluster. So we have one active node and we brought up two more. They both tried to join and etcd is doing its thing to do leader election and figure out who all of its members are. And the first node that connected is in a learner state. The cluster is trying to figure out who it is. The next node that connects won't actually connect because there's already a node in a learner state. So you've got a couple of options here. You can either wait for the second node to come up, or you can just try that again and hope that somewhere along the way it got past the learner state and has moved on. And it looks like that's the case here. So it's just going to result in a little bit less of a wait, but there's still going to be a wait. All right, demo B just popped up. It's still in a not ready state, but it's happily flooding our output up there. It's got its roles set now. And in a moment, it should go to a ready state. And then in a minute, we'll see demo C pop up as well. Okay, demo C is coming up now. It's got its roles, and now it's ready. So we've got three nodes in a ready state, and now We have 3 kube-vip pods because that was running as a daemon set. We can see that they elected demo A as the leader. So demo A is the one that's been up for the longest time. So that's going to be him. Still ARPing for the address. And that's that. RKE2 puts the Kubernetes config file in etc rancher RKE2 rke2.yaml. If we copy that over and edit it to change the server to 10.68.0.81 on port 6443, we can make a query to the VIP and we get a response. So what we've just done is we've created an RKE2 cluster that's highly available with a floating IP for the Kubernetes API Server. That's great. From here, we can go on to install the cloud provider to start using it. In fact, in this particular cluster, we didn't install the Nginx ingress controller so that we could go and install it now and have it do a load balancer service so that it gets a floating IP and we get all of the happy high availability goodness. But rather than do that, because I already covered that in the K3S video, let's move on and show how we can do this and service load balancing inside of a Rancher deployed cluster. I've already deployed RKE2 from Rancher, and it's here as a cluster called kube-vip demo. It's running on 3 nodes, demos D, E, and F. But because we want to use the same information, before I can use those, I'm just going to go in and shut down A, B, and C. When I deployed these from within Rancher, I did it slightly differently from how I did it during the live stream. Understanding that I want these to be kube-vip nodes, under networking, I put the TLS SAN, the server alternate names, to include the host name of each node. The reason for this is because when Rancher deploys RKE2, the same certificate is used on multiple nodes. So we don't have the ability to say use this TLS SAN for this node and this for that one and this for that one like we did when we deployed RKE2 manually a moment ago. So here we've got demo D, demo E, demo F, demo cluster, and 10.68.0.81. The other thing that I did, which is different from the live stream, is when I enabled the authorized endpoint, I did not provide an FQDN. What I learned since the live stream the other day is that if you provide an FQDN, then the authorized cluster endpoints only give you the FQDN. For those of you who aren't familiar with RKE and RKE2, an authorized cluster endpoint is a way to communicate directly with nodes on the cluster when it's been deployed by Rancher. The example here is if you have a person in Australia, a Rancher server cluster in New York, and it's managing a cluster in California, the person in Australia shouldn't need to go all the way out to New York to talk to Rancher to come all the way back to California and talk to the cluster. So when you enable Authorized Cluster Endpoint, or ACE, Rancher takes the user configuration and pushes it down to the cluster, and then gives you a kubeconfig file that enables you to communicate with all of your specific role-based access control privileges directly to the cluster itself. If you give it an FQDN, what it expects is that you have a load balancer in front of the control plane nodes in your cluster. That is what the FQDN would resolve to. That load balancer is expected to have its own TLS certificate, probably from a real CA. So you don't need to give it CA certificate information here in the other box, unless you're using a self-signed certificate, in which case you do need to give it a certificate here. By not putting anything here, what we actually get in our kubeconfig, and I'll just go and grab that right now, is a configuration block for each individual control plane node. In our case, that's basically what we want, and we're going to copy that out to do something a little bit more useful. So here's the kube-vip demo kubeconfig. And you can see that kube-vip demo actually connects to Rancher. Rancher acts as an authentication proxy. But then we also have demo F, demo E, and demo D for directly connecting to each of those control plane nodes. In most cases, this would be fine. You could just decide, if one of your control plane nodes is down, you could connect to a different one, but it requires that you make some manual changes. By putting the VIP in front of it, well, it's just going to move to whichever control plane nodes are still active. First, we have to install kube-vip. So here we have nodes D, E, and F, and there's two ways that we could do this. We can install kube-vip on all three of them, but because the way that we're doing it is by dropping a file into that watched directory, we really only need to do it on one of them, and it'll just get installed into the cluster and it'll do what it's supposed to do. So let's just put it on demo D. We'll follow the same steps that we had before. We'll set all those environment variables. We'll skip the RKE2 installation, and we'll just go right to the kube-vip installation. Good to go. And now we can go, well, let's come over here. Let's talk to kube-vip demo. KCC is using the wonderful kube command, which allows you to very rapidly switch between Kubernetes contexts across all of your Kubernetes config files. Let's change our namespace. We've already got 3 pods running. Let's look at one of them. New leader elected demo D. There we go, ARPing for it. There's our address. So now, let's just edit our file here. Let's grab one of these blocks. That's line 47. We'll yank from line 47 down to line 60. Paste that, and we'll call this kube-vip demo VIP. We'll change this to our VIP address. The cert data stays the same. And then down under contexts, let's create a new one of these. Now you'll see that when we go ahead and load this up into Kubi, we have a new one called kube-vip demo VIP. And now when we say kubectl get pods, well, there we are. So now we have replicated what we just did in the standalone RKE2 cluster by deploying kube-vip as an HA solution for the Kubernetes API in our Rancher deployed cluster. So we've reached parity there. The next step is to install the cloud provider from kube-vip, which enables LoadBalancer Services. It's really easy to do. Let's jump back over to demo D. And what you just saw go by, let me actually nuke these. All right, what you just saw go by is I once again pulled down some YAML directly from kube-vip for the entire kube-vip cloud controller, and I wrote that out to that watched directory. Then I wrote out a config map, which simply gave a global range of addresses that kube-vip can use. Kube-vip can assign addresses from a global range, or it can assign namespace-specific addresses from a range just for that namespace. This is helpful if you want to control egress or ingress or anything for workloads running in a particular place so that you can just wrap that around a namespace. We're just going to make it global to keep things easy. Then I copied that config map out to that watched directory, and now there should be a stateful set for kube-vip cloud provider. And it's just up and running. So the real test of this is to deploy something with a load balancer service and see if it works. We can do that quite easily with our beloved Nginx pod. So we'll create an Nginx deployment, running just Nginx stable Alpine, and then we'll go ahead and expose that deployment on port 80 as a load balancer service. And you can see that we have an Nginx service. It's a load balancer. It's listening on 1068.1.121. If we curl that, boom, we get the Nginx page. So we've got 1068.0.81 is load balancing the Kubernetes API server, and then that global range, it just grabbed one of the addresses from it that's available and started ARPing for that for our load balancer service. So now we have a Rancher deployed RKE2 cluster with an HA load balanced Kubernetes API server that's able to run load balancer services using kube-vip. This is perfect for an on-prem environment. Let's do a quick test and let's see how long it takes for kube-vip to fail over the IP address for the Kubernetes API server. First, we want to make sure that we're powering off the right host. And we'll set up a ping. And then we'll shut it down. Seven seconds. That's not bad. So let's bring that node back up and run the same test with the service load balancer. You gotta wait for it to come back into a ready state. And while we're waiting for that, let's find out where the address moved so we know what host to shut down next. That's interesting. It actually looks like they did leader election again and the address moved back to somewhere. Demo E. And so that's this guy right here. There we go. So now we'll set up a ping on 68. Let's see. Set up a ping on that, and we'll go shut down demo E. That one took a little bit longer, from 31 to 41, so 10 seconds. But honestly, 10 seconds for failover of an address, that's not that bad. Just because we've deployed kube-vip doesn't mean that I don't love MetalLB. The reason for using kube-vip is for the HA API server load balancing, which MetalLB just doesn't do. That might be enough for you. You might already have a MetalLB infrastructure, but you can deploy kube-vip separately for just that function. As far as the load balancer service component goes, in my opinion, they're pretty much the same. That's all I have for you today. Thank you so much for watching. I'll see you in the next video, and until then, stay caffeinative.